College Algebra, Topic 2.1. We're going to simplify these complex rationals. First, we need to find all our denominators, so let's list them here. Our denominators are x plus 1, here, x squared minus 1, and here x. Now, I want to make sure I have all factors, so right now I'm going to expand this one right here, because this is the difference of two squares. So my denominators would be x plus 1, x plus 1, x minus 1 for this one, and then x again. Alright, so now from here, now that I can see all my denominators as prime factors, I can get the least common denominator, LCD. I need at least one single x here, single x, so I need a single x. I need a single x plus 1, and I also need a single x minus 1. Again, he has a single x plus 1, he has a single x plus 1, therefore we need only a single x plus 1. So this is our LCD. Now I'm going to multiply this LCD times the numerator and denominator. The LCD over LCD is equivalent to 1, so it means that we're not actually changing the problem by multiplying it by 1. So LCD divided by x times 2 would leave the x plus 1, x minus 1 in the 2. The LCD divided by x plus 1 times negative 2 would leave a negative 2 and an x minus 1. The LCD divided by x squared minus 1 is dividing it by x plus 1, x minus 1. That'll leave an x times 2 will give us 2x. And the LCD divided by x would leave the x plus 1, x minus 1. Okay, I'm going to combine the x plus 1s, x minus 1s into difference of two squares. So this would be 2 x squared minus 1 minus 2 times x minus 1, 2x plus, and this would be x squared minus 1. Alright, now then I'm going to distribute here and here. That'll give me a numerator of 2x squared minus 2 and negative 2x plus 2. And the denominator, I'm going to rearrange this to where the this is in descending order. So we'll start with x squared, then the 2x, and then the negative 1. And from there, I'm going to cancel out the 2's, so I'm left with 2x squared minus 2x for the numerator, and x squared plus 2x minus 1 for the denominator. And also, I've checked my denominator. When I try to turn this into two binomials, I find that this is prime. This will not factor, because x times x and 1 times 1, and this, if the signs are different, will not create a negative 2x. So this is my final answer. Number 6. The negatives here, exponentials, means that we can take the reciprocal of the base. So this becomes 1 over x, and this becomes 2 over y. This remains 2y plus 4x. Now my denominators will be x, y, 1, and 1. X, y, denominator here is 1, denominator here is 1. So this means my least common denominator will be xy. Now I'm going to multiply the numerator by xy and the denominator by xy, or the LCD, which is equivalent to 1. And so the LCD divided by x times 1 leaves y. The LCD divided by y times 2 is 2x. The denominator, I'm simply going to multiply or put xy on the opposite side here. I'm not going to distribute this one. 2y plus 4x. Instead of distributing, I want to keep it factored. In fact, I'm going to do more factoring for the denominator. I'm going to factor out the greatest common factor of 2. So what that'll leave us is 2xy times y plus 2x. And now we have common factors right here, 1 and 1. So this becomes 1 over 2xy. Number 3, we want to rationalize the denominator. We rationalize the denominator by using the conjugate of square root of 10 and square root of 6. The conjugate will be square root of 10 plus square root of 6. And to make this equivalent to 1, we're going to put square root of 10 plus square root of 6 in the numerator as well. This all makes this equivalent to 1. Now, for the numerator, we're going to do the FOIL. In fact, x plus 10 times x, not x, the square root of 10 plus square root of 6, got those x's on my mind, multiplied by another square root of 10 plus square root of 6. I'm going to use binomial expansion for that. The binomial expansion will be a squared plus 2ab plus b squared. So a squared would be 10 plus 2 times a times b, that's a times b, which is square root of 60, plus b squared, which will be 6. In the denominator, the binomial expansion will be a squared minus b squared, because what we have are conjugates here. So a squared will be 10 minus b squared will be 6. Alright, now any perfect squares inside 60. Let's say 4 times 15. So let's add the 6 and the 10 together. We'll get 16 plus 2 times 2 with a 15 remains inside the roots. And 10 minus 6 is 4. So what we have here is a 16 plus 4, 15. That's over 4. And we can break that up into two pieces. 16 over 4 plus 4 square root of 15 over 4. This will reduce down to 4, and this will reduce down to the square root of 15. Okay, once again, the i's. The i's are actually roots, square roots of negative 1s. So to rationalize the denominator, we must multiply by the conjugate, which is 4 minus I. And 4 minus I in the numerator as well, which all is equivalent to 1. Okay, what I have in the numerator, once again, is, let's see, this is 4 minus I, so I'll use binomial expansion on this. So this will be a squared, which is 16, minus 2 times ab. ab will be 4i, so that'll be 4i, it'll end up being negative 8i. And then negative times negative is positive I squared. In the denominator, we're going to have 4, we have conjugates, so it'd be 4 times 4, which is 16, and minus I squared. Alright, so let's simplify these. The negative 2 times 4i will be negative 8i, and I squared is negative 1. Here I squared is negative 1, but times negative gives us positive 1. So altogether, we have a 16 and a negative 1, which is 15, and a negative 8i. And the 16 and 1 makes 17. And this doesn't simplify even if I were to split it up into two pieces. That's 15 over 17 minus 8i over 17. So either one of these answers are okay. It just doesn't simplify.